Have you ever noticed that brilliant light at dawn or dusk? That's Venus, our brightest planet, not a star. For millennia, it's captivated us, earning names like Phosphorus, Hesperus, and Venus. Its beauty is deceiving. Beneath those pale yellow clouds lies a world of extremes. For centuries, we could only guess what was hidden below. Paradise, jungle, or something far worse? Now NASA's latest images are pulling back the veil. Imagine a world where the sky rains sulfuric acid and the ground melts lead. This is the real Venus, a planet of crushing pressure and searing heat. The story of Venus is a cosmic detective story, with clues revealed by radio waves, infrared, and robotic explorers. Each discovery rewrites what we thought we knew, revealing a world both alien and eerily familiar. Venus's mystery fueled wild speculation, lush forests, tropical climates, even oceans. But reality is far more shocking. Venus is a cautionary tale, a world so similar to Earth, yet so drastically different. As of November 29, 2025, we're closer than ever to understanding our planetary neighbor. Robotic missions now see through the clouds, map the terrain, and analyze the rocks. These pioneers are helping us answer questions that have puzzled us for generations. What happened to Venus, and could it happen here?
Venus is our closest planetary neighbor, the second planet from the Sun. It's often called Earth's twin, almost the same size, mass, and composition. Both have solid surfaces and atmospheres, and both sit in the Sun's habitable zone. From afar, Venus looks like it could be another Earth. But the similarities end there. A day on Venus is longer than its year, and it spins backward. On Venus, the Sun rises in the west. The real difference is the atmosphere. Venus's is a thick, crushing blanket of carbon dioxide, over 90 times denser than Earth's. Surface pressure equals being nearly a kilometer deep in Earth's oceans. This thick CO2 traps heat, creating a runaway greenhouse effect. The result? Surface temperatures soar above 465 degrees Celsius, hotter than Mercury, despite being farther from the Sun. Any water Venus once had has long since boiled away. There is no liquid water now, only a scorched, dry wasteland. Venus is not just Earth's twin, it's Earth's twisted sister. It's a stark reminder of how fragile a planet's environment can be. Two similar worlds, two radically different fates. Venus shows us how quickly paradise can become a nightmare. Its story is a warning and a mystery. How did two sisters become so different? For decades, we imagined Venus as a steamy, tropical world. Jungles, swamps, maybe even dinosaurs. Its thick clouds were thought to be water vapor, promising rain and oceans. Science fiction ran wild with visions of a second Eden. But science is about evidence, not wishful thinking. The first clues came from radio telescopes in the 1950s and 60s. Venus emitted intense microwave radiation, hinting at extreme surface heat. Some hoped the heat was high in the atmosphere, but data kept piling up. The dream of a jungle Venus faded. Robotic probes finally settled the debate. The Soviet Venera landers survived just minutes on the surface, but sent back the truth. Temperatures were hellish, pressure was crushing, and the clouds were sulfuric acid. The first images showed a rocky, desolate landscape under a dim orange sky. The paradise was a myth. Venus is a furnace, not a garden. Our neighbor's true nature is far more terrifying than we ever imagined. The leaden. Reality is often stranger and harsher than fiction. Venus's story is a warning about the dangers of unchecked change. It's a world transformed by forces we're only beginning to understand. The real Venus is a fiery inferno, not a lost paradise. Venus's surface is hidden from view, but radar changed everything. By bouncing radio waves off the planet, we built the first maps of its mysterious terrain. NASA's Pioneer Venus Orbiter in 1978 gave us a rough global map, revealing highlands, mountains, and plains. The Soviets' Venera 15 and 16 mapped the northern hemisphere in detail, uncovering volcanoes, corona, and vast lava flows. These missions showed Venus was shaped by immense volcanic forces, but the real breakthrough was NASA's Magellan spacecraft in the 1990s. Magellan mapped 98% of Venus's surface in high resolution. It revealed thousands of volcanoes, winding lava channels, and vast plains. Unlike Earth, Venus has no plate tectonics. Its surface is shaped by volcanic activity alone. Magellan's maps are still our definitive guide to this alien world. Thanks to radar, Venus is no longer a blank spot on the map. We now see a world of dramatic geology and violent history. With Magellan's maps, we can tour Venus's surface, virtually. Start with Aphrodite Terra, a continent-sized highland near the equator. crumpled by immense geological forces. To the north lies Ishtar Terra, home to Maxwell Montes, taller than Everest, possibly dusted with metallic snow. Most of Venus's vast lowlands like Guinevere Planitia, flat plains of solidified lava, resurfaced by massive volcanic eruptions. Few impact craters mean Venus's surface is geologically young, just 500 million years old. Then there's Beta Regio, a giant shield volcano hinting at ongoing geological activity. These features, crumpled continents, metallic mountains, volcanic plains, define Venus's hostile face. It's a world shaped by forces far more violent than anything on Earth. The landscape is alien, extreme, and ever-changing. Exploring Venus, even virtually, reveals a planet of relentless transformation. Every feature tells a story of upheaval and renewal. Venus is a world in flux, its surface a testament to cosmic violence. This is the true face of our sister planet. Deep inside, Venus and Earth are similar: core, mantle, crust. But on Earth, the crust is broken into moving plates, driving earthquakes, volcanoes, and mountain building. Plate tectonics helps Earth release its internal heat gradually. Venus is different. Its crust is a single unbroken shell, a stagnant lid. No plate boundaries, no subduction zones, no recycling of crust. So how does Venus release its heat? Scientists think heat builds up for millions of years, then erupts in planet-wide volcanic cataclysms. Massive lava floods resurface the planet, erasing old features and craters. This explains why Venus's surface looks so young. Instead of steady change, Venus undergoes cycles of quiet and violent renewal. Its geology is a story of catastrophic revolution, not gradual evolution. Venus's stagnant lid is a key to its hellish transformation. It's a planet shaped by rare global upheavals. Why don't we have rovers on Venus like we do on Mars? Because Venus is the most hostile planet to visit. Surface temperatures melt lead, electronics fail in minutes. The pressure is like being 900 meters underwater, enough to crush submarines. Landers need thick, heavy hulls, and powerful cooling. But even the best survive only briefly. The atmosphere is toxic, filled with sulfuric acid clouds. Acid rain evaporates before reaching the ground, but it's deadly during descent. The thick atmosphere makes landing tricky, like descending through soup. These challenges make Venus a robotic graveyard. Every mission is a battle against heat, pressure, and acid. Venus fiercely guards its secrets. Exploring it is one of space exploration's greatest engineering feats. Human boots on Venus's surface? Not likely. Our technology can't handle the heat and pressure, but high above, at 50 kilometers altitude, conditions are surprisingly Earth-like. Here, pressure and temperature are comfortable, and NASA's Havoc concept imagines floating cities in the clouds. Airships filled with breathable gas could float naturally in Venus's dense atmosphere. These cloud cities could host scientists, protected from radiation and with gravity close to Earth's. The idea is bold. Live in the sky, not on the ground. Challenges remain: sulfuric acid, building reliable airships, and safe transport. But the vision is powerful. Humanity adapting to Venus, not conquering it. The future of Venus exploration may be in its clouds. Floating above the inferno, we could finally study our sister world up close. Venus still holds profound mysteries. Did it once have oceans? Could life have started before the climate turned deadly? Finding evidence of ancient water is a top goal for future missions. Is Venus still geologically active? Recent data hints at ongoing volcanism. NASA's Veritas and Da Vinci Plus will search for answers, mapping the surface and sampling the atmosphere. Could life exist in the clouds? Strange chemical signatures fuel speculation, but only direct exploration will tell. Venus is a cautionary tale, a scientific mystery, and a destination for future explorers. Its story reminds us how fragile habitability can be. As we unveil Venus's secrets, we learn more about our own world. The morning star is waiting. What will we find next?